you've watched some of my other videos, you'll know that I recently got back into cassette tapes. And that led me to start searching through an old storage tub of mine to see what tapes I still had left from when I was a kid. And I was mostly searching for anything that was still worth playing, especially now that I have much better equipment to play it on. But I stumbled across something that made me wonder if these tapes aren't what they say they are, and it has to do with this cassette deck's ability to display the tape type when it's inserted and the claims made on these cassette sleeves. And that's what this video is all about. Did the tape companies dupe us into buying tapes that claim to be better than they actually were? Let's find out.
So real quick, to make sure we're all on the same page, for those of you who may not know, there are 3 different types of audio compact cassette tapes. Type 1, a Type 2, and a Type 4. Now, without going into too much detail, these types differ in their magnetic properties, which affects the bias level, or the dynamic range, during recording, and ultimately its replay quality. This is done in combination with the tape itself, and the tape deck technology being set to match the tape formulation being used. You can visually identify the different types by inspecting 2 things. One, the magnetic tape colors are different, and I use my own silly method of comparing them to the color of chocolate as a way to see the differences. So here's a Type 1 tape, which is like a light milk chocolate. Here, this Type 2 tape looks like regular chocolate, and this Type 4 metal tape looks like dark chocolate. And second, there is also another way to identify them, which is probably the easiest, and that is by looking at the notches at the top of the tape. Now, all tapes have these first set of notches, and if these notches are present, you can record. If they're missing, you can't. Now, Type 1 tapes can be identified because they only have the record protection notches here. Type 2 tapes have an empty notch next to these record protect notches, and the Type 4 tapes have notches next to the record protect notches and in the center of the cassette. Now, to play these tapes properly, to get the most out of them, early model tape decks required manual selection of the tape type. But modern decks have these little sensors that detect the notches when a tape is inserted. And this is where this story really begins. Like I mentioned at the beginning of the video, I was searching through a storage tub looking for some old tapes to play, and I came across this original Bryan Adams tape, which has this claim on the cover. A&M on BASF, Chrome in big letters, with the tagline, "Music that shines," and underneath that it says 120 microsecond EQ, which is a playback standard. Now, remembering what I said just a moment ago about the different tape types, Type 2 tapes have a chromium dioxide magnetic formula and are commonly referred to as chrome tapes. And chrome tapes are dynamically better than Type 1 tapes. So, if it's 1985 and I'm in a store about to purchase this tape, I have every reason to believe this tape is a Type 2 chrome tape and is going to sound better than other predominantly Type 1 pre-recorded tapes. So imagine my surprise when I inserted this original Bryan Adams tape and saw this. Okay, so let's check to see if there are any type notches on the cassette itself. And that's a big no on the Type 2 notches. Looks like there's only write protect notches here. At this point, I'm guessing it's possible that automatic tape detection on tape decks may not have been invented yet, so maybe the sleeve will make mention of manually selecting Type 2 for the playback of this tape. Okay, so this is really interesting. Here on the inside of the sleeve, the manufacturer, BASF, states, "This cassette is manufactured with BASF Professional 2 chrome tape. Your cassette player should be set at normal and not chrome for optimal sound reproduction during a playback." Wait, what? Okay, so it is a chrome tape, but I shouldn't set the deck to chrome? Then what's the point of going out of your way to chrome up your sales pitch if you're not going to unleash its full potential? Apparently, the real reason here is not its false chromeness, but rather this seemingly misunderstood 120 microsecond playback EQ standard in relation to frequency response, tape hiss, recording levels, player compatibility, and some clever marketing. Type 2 chrome tape formulations have less noise, or tape hiss, than Type 1 tapes by their very nature, and frequency response, or its range of playbackable sound, should be extended a bit more than that of a ferric tape. But a chrome tape won't necessarily sound better than a Type 1. It's that the chrome tape should sound quieter noise-wise, particularly if the musical content has a lot more high-frequency energy and is recorded at a higher volume. And by the looks of it here on the spectrum analyzer, this tape does in fact have a high dynamic range. But you can't simply lower noise by recording at a higher volume. You can, however, increase the dynamic range by increasing the recording level volume as long as you adhere to the signal-to-noise ratio of the tape itself. So, if the recording level is the same as that for ferric tape, the Type 2 Chrome tape will have about 4.7 decibels less noise at the 70 microsecond playback EQ, and an additional 3 decibels less noise at the same 120 microsecond playback EQ. Additionally, many pre-recorded tapes that use Type 2 tape were duplicated at 120 microsecond EQ and were manufactured in order to have the highest playback compatibility among consumer tape decks, because not all decks had the option to choose the tape type, regardless of it being a fairly standard feature on most tape decks by the mid-80s. So what does this mean for the BASF Chrome claims on this sleeve? As it turns out, this Type 2 tape was recorded with 120 microsecond EQ for playback using the normal bias, or Type 1 setting, not only for consumer tape deck compatibility, but also for improved output levels and low noise. That means this 120 microsecond EQ Chrome tape should be played on the normal bias Type 1 setting. To me, this was all just a clever marketing tactic of saying, in other words, you'll hear the same dynamic range on this tape no matter what deck you play it on, but we know that you know that Chrome is better, so we'll label it with the name Chrome. Okay then, so what about an actual pre-recorded chromium dioxide tape? It says chromium dioxide in big letters on the sleeve, so let's insert it and see what my tape deck says. Now hold up. This tape was released in 1988, and I know for a fact that auto tape type detection was already a thing by this time. Check out this page from the 1987 Sony ES catalog that clearly mentions this feature. It states automatic tape type selection makes it impossible to accidentally record or play with the wrong bias equalization. Impossible, you say? I don't know about that. So far nothing's worked for me and I'm only 2 tapes in. But I'm not going to blame the tape deck. It's actually doing its job just fine. It's the cassettes themselves that seem to not adhere to agreed upon standards. Incidentally, I also searched the liner notes and could not find any mention of manually selecting chromium dioxide on the player. Upon further inspection of the cassette, it appears that there are cavities for the notches, but the notches haven't been removed. And that's what's frustrating about this whole thing. Well, I'm going to take matters into my own hands and force its compliance. And since I can't modify the deck, I'm going to modify the cassette. I thought of a variety of ways I could carve out notches without damaging the cassette, while at the same time making the holes as smooth as possible, since it still has to be inserted and auto-detected. As you can see, I ultimately decided to use a thread burner, which is why I'm outside. The end heats up super hot and slices through it like a hot knife through butter. I also used a small triangle file to smooth out any remaining rough edges, and I think I did a pretty good job. Alright, so now the moment of truth. Was I able to force this tape from its Type 1 captivity into its real Type 2 self? Success. I'll try to avoid a copyright strike and only play a tiny segment from each version to see if you can tell the difference. First up, we'll use the Type 1 playback settings. I taped over the hole I made to force it back to Type 1 for that demo, so now I'll remove it and it'll go back to Type 2. And the deck will confirm that I did that correctly. Okay, here's playback using Type 2 settings. Honestly, I didn't really hear a difference or see anything different when comparing them on the spectrum analyzer, but I'm guessing that while it was in fact a chromium dioxide tape, the tape manufacturers didn't try to achieve its maximum dynamic range. And that's what brings me to the point of this video. The past is the past, and whatever the record companies were doing back then to mass produce and market pre-recorded tapes is over. But I see cassettes making a comeback in a similar fashion that vinyl did, and that's a great thing. But the difference is, we all know how good music can sound because of the digital era we live in. And those of us who record on tapes also know the dynamic range potential that can be achieved. So I'm basically making a plea to the record industry. If you start to release more and more music on cassettes again, and I hope you do, please stick to the established tape standards, be straightforward about the tape type without any clever marketing, and please, please, please duplicate tapes using the maximum dynamic range achievable. If done right, I predict a resurgence in cassette popularity that could resurrect this often dismissed format into a viable player once again in the world of music. If you enjoyed what you saw, please consider liking and subscribing. Thanks for watching.